Okay, great. So it looks like it's recording. So we're going to do a brief demo of the inspectAR software and how it can be used to significantly reduce the amount of time and frustration when dealing with electronics in the lab. So what we have here is a 12-layer board, a pretty complex PCB with some really complex parts like this dense BGA, and then a bunch of other components on the top and bottom side, and with little to no room for silk screen for a lot of these components as well. So in this example, let's say you wanted to know more about this particular IC on the board, looks like the main one. Normally, if you had to figure out what pins connected to what other signals and what other components on the board, you'd have to do a bunch of context switching around your different documentation and things like that. But with this tool, you can just click on the IC like he's done here, go to a pin, as you see they're highlighted in blue on the board itself, and just click create attach net overlay. And now you'll see on the bottom there, maybe you can zoom in a little bit, where that actual signal flows. It looks like it goes to the bottom side of the board and onto this IC over here in the bottom left of the screen, where if Liam clicked it, you can actually go in and just see what that IC is connected to and what that IC is. And looks like if we go to the info, yeah, it looks like it's a clock generator signal. You get the info. You can even request part information and get all that info within seconds, which normally would take much more time, probably emailing and talking with a bunch of other engineers just to get something simple. So this really democratizes the way that hardware is done. You can even get into the data sheet right here, go through the whole thing, and then kind of minimize and save it to the dashboard right up there. So that's the basic functionality of the tool. Two other kind of key features that we wanted to highlight are the ability to find any signal on the board and kind of create a virtual test point for it more intuitively than maybe going through your schematic and finding the bottom part of a random passive component to see where to tap into a signal. Let's use an extreme example, ground. So all you have to do is search ground. It'll find that entire signal and overlay it on the board. This is the back side. That's why you see the bottom layer change. You can even edit the color of every single layer within this tool if you wanted to, just right there, which we're fine now. And you can even edit the transparency of it if you wanted to kind of get a better glimpse underneath. So if you had any other probes or other components you wanted to see. But in this example, that's still not that useful for you to actually go and do something meaningful like probe the board. So in this example, we're on the bottom side of the board. Let's say I just wanted to find exposed copper, an area on the board, like a pad, something that I can actually go probe. So I'll deselect traces, vias, and fills, and I'll turn off the top layer as well. And now I can see pads that are connected to ground on the bottom layer that I'm looking at, and I know exactly where I can probe, whether or not I had an explicit test point or if I'm in a kind of a high frequency area where I need the closest ground point or something like that. And you see Liam's finger is going over the board and it's still so much as shakes. So it's incredibly stable, and this is a live view of the board that's on the desk. And then the final thing is just if you have to search components, whether you're doing a debug, a rework operation, or even a hand placement and assembly, you could search for anything. So in this case, let's search for a component like C25, or yeah, in this case, if you do just randomly C25, maybe you told a technician to do is, hey, rework C25, swap it out with a different value. So one, you already get the value and all the information there. But in this example, you can actually go there, zoom in, and it'll highlight it immediately. It looks like this is an 0201 component. And within 2 seconds, we found it, got all the information about it, the package size, the value, all the other properties and parameters. You can get into the data sheet if you wanted to. It's an X7R cap. And you can do this for any component or set of components, whether you're assembling by box and you want to search by a particular value and highlight all the components that have that same value so you can do things one at a time, or any other kind of set of operations. inspectAR is the tool that makes it significantly easier to do so. So in this final example, we just did a batch of a bunch of different resistors. So if we turn off maybe the older caps, we see these are highlighted in more of a bright hue. You can see that immediately I know on the top and bottom layer, this is where these components are. And you can walk anybody through that operation, or if you're working on the board yourself, it's immediate. So that's really the basic functionality of the tool. I know we went through it pretty fast, but it gives you a good glimpse in how people are using it in their own R&D groups, but also how FAEs are using this to interact with their customers and kind of walk them through a debug or any sort of onboarding information that you might want to do. This tool makes it significantly easier. So that's all. Thanks, everyone.